Hi there, so I've got this new phone and it's got a USB-C connector on it, which is one of these ones you can plug in either way round to replace the older style micro USB. So it came with a charging cable and a conventional looking charger with a USB-A connector on it, plug and socket. So I went to buy some more of these cables on eBay so I could leave them at different places like at work, and also some USB on the go adapters so I could plug memory sticks and so forth into the phone with a USB-C on it again. And then I started getting really confused because the cables arrived, and then I started getting worried about whether they were dodgy quality or not, because I read on eBay that if you buy cheap USB-C cables, they can lead to the charging current being too high on your charger and for it to damage the charger or the phone, or if you're charging off something like a computer, it can damage the computer. So I looked into it a bit more, and it said that if you were going to a legacy connector like a USB-A, there had to be a resistor inside the USB-C plug to tell the device it couldn't charge at the higher rate, which was quite confusing because this fast charger that came with the phone has a USB-A on the end. Well, reading about it in more detail, and there's a whole load of notes here, USB-C is very complicated. It says that the resistor just tells it that it might not be able to charge at the higher rate, and it might be able to negotiate via the data lines a higher charge rate, which I assume is what's happening on these on this charger that's come with it. But then I needed to check whether these other things had the resistor and the on-the-go adapters I'd bought and the extra USB leads. And the only way I could think of doing that was to buy some sort of breakout board. So I bought this circuit board, and these were just a couple of quid on eBay, which has got a USB-C connector and then breakouts for all the connections. So we've got the ground on the left. CC1 and 2 is where these resistors are connected between there and ground, or there and V bus on the right, which is the 5 volts line. So I think now when I can plug my cables in there, I could check whether they've got these resistors or not. However, there's an added problem that the board has already got 2 resistors on it. You can see them to the left and right of the connectors. And these are 5.1 kilo ohm resistors, which are for use when you're, so it can tell the device that it's, whatever it is, connected to a legacy USB device, because these are only the legacy data lines and not the new TX1 and 2s that are available on USB 2. So the first thing I've had to do is break the tracks to those resistors, one just below the resistor on the right there, and then one on the other side of the board to break that track there on the right of the board. So now we can measure the resistance between the CC lines and both V bus and ground, and find that there's infinite resistance there. So I've successfully chopped those out, those resistors, and I can use it now to measure the same resistance when I've got my USB-C cable plugged in to see what resistor there is in the cable. So we're going to do that now for a variety of cables. Another useful gadget is this USB charger doctor, which gives you the current and the voltage of any charger when it's plugged into something. So at the moment I've got about 5 volts, which I should have, and 0 amps because there's nothing plugged into it. Sorry, this new phone's really awkward to hold. So if I plug it into the phone now, you can see it's drawing a current. And it's going at the fast charge rate, 2.4 amps. So that's just another useful thing to have around, really. Only cost a couple of quid again. So the specification document I've got says there should be 56 kilo ohms between V bus and CC. And elsewhere in there it says you have to use 2 separate resistors for the CC1 and CC2, which are the connections. Basically, one of them's for when you've got the plug plugged in one way round, and one's when you've got it plugged in the other way round into your device, since the connector will go in both ways round. So measuring that resistance on the Motorola cable between CC1 and V bus, we've got 56.1 kilo ohms, that's right. But between CC2 and V bus, we haven't got anything, so that's slightly wrong. That only matters in a few special circumstances when, say, the CC lines might be tied together in the device or something, so that's probably okay. And there's infinite resistance between CC1 and CC2 and ground as well, which is right, they're supposed to be open. So we find that the Motorola cable sort of almost meets the specification. Doing the same thing on one of the cheap eBay charging cables, we find exactly the same thing, infinite resistance to ground and nothing between CC2 and V-bus, and 55.5 kilo ohms this time, so slightly wrong but probably close enough, between CC1 and V-bus. And I found the same for this longer charging cable I bought on eBay, 55.3 kilo ohms this time, so again close. So I'd say those two charging cables are probably okay, unless you've got some funny thing happening with your second CC line. So I'm guessing it was probably overkill when I got panicky and bought some anchor cables on eBay, although they were sort of new old stock or something, so I got 3 for £10, so it wasn't too bad, although they're all short ones, so I've got to buy USB-A extenders. Then to my USB on the go cables. So the first ones I bought on eBay were a bit shocking when they arrived. They had these hard plastic cases with all glue around them, which I've broken open. And you could sort of rotate the cable inside the casing, which gave the impression that there wasn't any strain relief in there. And indeed there isn't. I've snapped these apart. Then there's absolutely no strain relief in there. Soldering actually looks okay on the end, on the USB-C end. And there is a circuit board with a resistor in there, which looks sort of hopeful. On the USB-A socket end, so this is where you plug your memory stick or whatever. Now these have obviously been hand soldered on the other end of the cable, and I don't know how well you can see on this new phone, which isn't perhaps as good as a high quality phone, but the black wire at the top, which is the ground, you can see there's a what we call a whisker, which is a stray strand of wire which is very close to one of the data lines, so that could have given problems. So I think, well, this one's obviously going in the bin that I've smashed apart, but the other two I've just left in stock so I can potentially reuse the connectors if I ever need to. And then the replacement ones I got were again unbranded, but they looked a bit better on eBay. They've got this sort of ribbon cable affair. At least they're over moulded, which means that whoever produced them had some quite good production facilities. So now I'm going to test the resistances on these USB on the go cables, which, as we see on here on the list, so a USB-C plug to a Type A receptacle is supposed to have 5.1 kilo ohms between the CC lines and ground, and nothing between the CC lines and V-bus. So testing the cheap and nasty one first, we find we've got 5.1 kilo ohms. That's between the CC2 connection and V-bus, and ground, which is what it's supposed to be, but there's nothing on the other side, nothing between CC1. It's also worth saying that that cheapy USB on the go, when I was plugging it into my breakout board, the connector was very stiff and felt as though it was going to break the socket. So the better USB on the go, the over moulded one, has exactly the same connections with a 5.0 kilo ohms between the CC2 and ground. So there's the same pattern with all the cables. So I think probably maybe this thing is wrong when it says you should have separate resistors between the CC1 and CC2 and ground or V-bus. So I don't think there are any resistors missing in any of these cables, although I would warn against cables that look very cheap and nasty, that they might cause short circuits inside, particularly when they get worn or the cable gets pulled without any strain relief. And this board will be very useful for testing in the future any extra USB-C cables I get, to check they've got the resistors in place. Thanks for watching.